Algebra 2, Lesson 55, Finding Probability. We're going to be talking about theoretical probability and favorable outcomes. Probability is an experiment, and I'm going to read you the definition. For equally likely outcomes, the theoretical probability, P stands for that, of an event occurring is the ratio of the number of favorable outcomes to the total number of outcomes. So a favorable outcome is an outcome in the event. So I'm going to start with example 1 in your book. It says a calculator is programmed to generate numbers from 1 to 100 inclusive when the enter button is pressed. What is the probability of a multiple of 20 when the enter button is pressed one time? So for part A, our probability, each outcome, it's from the numbers 1 to 100. Each outcome is equally likely. So we're going to use this formula up here. So they ask, what's the probability of hitting a multiple of 20? And it goes from 1 to 100. There are only 5 multiples of 20, 20, 40, 60, 80, and 100. So we have 5 favorable outcomes. A favorable outcome is just what we want our answer to be. We want it to be a multiple of 20. So we're going to put 5 on top because there are 5 multiples of 20 between 1 and 100. And the total number of outcomes is 100 because you can have any number between 1 and 100. All you have to do now is reduce this. 100 divided by 5 and 5 divided by 5. 5 goes into itself 1 time, 100 goes into itself 20 times. If you want to write it as a decimal, you can. It's going to be 0.05 or 5 out of 100. The next part of this example 1 is part B, and we have a square here with a circle inside. The shaded areas are right here. The square is 12 inches by 12 inches. It says estimate the probability that a point chosen randomly inside this figure, inside this square, is in the shaded region. So if you were to just randomly go like that, what's the probability of your point landing inside of the shaded region? So we're going to use the number of favorable outcomes over the total number of outcomes. So our shaded area right here, we know the formula for a square. For the area of a square, it's length times width. And then the formula for, this is for a square, the formula for the area of a circle, it equals pi r squared. So what we need to do is we need to put the number of favorable outcomes. Basically, if we were to randomly touch it, we want our little dot to land inside the shaded part of this figure. What you're going to do to find out what the shaded part of the figure is, you're going to take the area of the square minus the area that's not shaded, which is the circle. So our probability equals the area of the square minus the area of the circle. And then the total number of outcomes that are possible is the area of the square, because if you land it inside this figure, it's got to be inside the square. So we want the area of the square on bottom. So the area of the square is length times width, 12 times 12, minus the area of the circle, pi r squared. So pi, the radius is just going to be halfway across. So it's going to be 6, half of 12. And that 6 is going to be squared, divided by the area of the square, which is 12 times 12. 12 times 12 is 144. 6 squared is 36. You write your coefficient first, and then pi, which is a number, but kind of think of it as a variable, over 144. You cannot cancel 144. You can't do that. You have to figure out what the top is divided by 144. If you use your calculator, it's going to be 0.2146. That's going to be about what it is. If you want to write that, you can put this in your calculator. 144 minus 36 times pi divided by 144. If you want to write it as a percentage, then it's just going to move the decimal place 2 places to the right. So it's going to be 21.46%. Either answer, written either way as a decimal or a percentage, is correct. Moving on to example 2, for part A, it says all of the parking spaces in a lot are labeled with 2 different digits so that each parking space is labeled differently. What's the probability that a parking spot chosen at random is labeled with 2 even digits? So this is a permutation. We're going to use our formula for permutations. N factorial over n minus r factorial. But first we have to figure out what n and r are. So n right here is 10, and r, we want to find out what's the probability that a parking spot chosen at random is labeled with 2 even digits. R is going to be 2, the number of objects. So to write this out, we have 10 times 9 times 8, and you go all the way down to 7. That's what a factorial is. Then right here, 10 minus 2 is 8, so we have 8 factorial on the bottom. The reason why I stopped writing times 7 times 6 is because these are the same. We can cancel them. All it is 10 times 9, which is 90. So the probability that you pick a parking spot with 2 even digits is 90. Or if you, this is our bottom number. We're going to find out, that's for permutations. We're going to find out what the probability is. Favorable outcomes. So the favorable outcomes, we have something with 2 digits. If you pick 0, 2, 4, 6, and 8, those are the even digits from 0 to 10. 0, 2, 4, 6, and 8 can be followed by any other 4 digits. So you could have 0, 2, 0, 4, 0, 6, 0, 8. Or you could have 24, 26, 28. But you cannot follow 0 with 0. You cannot follow 2 with 2. So to find out what the number of favorable outcomes is, we have the 0, 2, 4, 6, and 8. We have 5 of these. And we have to follow our first digit by another even digit. But we cannot use the same number twice in a row. So we can't do 0 times 0. So that means we're left with 4. So it's going to be 5 times 4 is going to be the number of favorable outcomes, 20. We're going to have 20 favorable outcomes. We're going to use this formula, favorable outcomes over the total number of outcomes. So we have favorable outcomes is 20, and the total number of outcomes is 90. You can cancel the zeros to reduce it. 2 over 9, if you want to write it as a decimal, it's going to be about 0.22, or as a percentage, just move the decimal 2 places to the right, it's going to be 22%. So the probability of finding a parking spot with 2 even digits is 22%. Let's look at the next one. A set of 22 books, volumes 1 through 22, are in a crate. If a student randomly chooses 5 books from the crate, what is the probability that the student picks either the first 5 volumes or the last 5 volumes? So there are books 1 through 22. The first 5 volumes would be 1, 2, 3, 4, and 5. The last 5 volumes, 5, 4, 3, 2, 1. So this is the first 5, this is the last 5. And the number of outcomes, this is going to be a combination, because if you chose the first 5 volumes, it's the same as choosing the last 5 volumes. So we have for a combination, this is our formula for a combination, n factorial over r factorial times n minus r factorial. Very similar to permutations. So the total number of volumes is 22. That's what n is going to be. R is going to be 5, because if you chose the first 5, you're going to have the same outcome if you chose the last 5. So if we replace n with 22 and r with 5, oops, we can solve this. Now you cannot cancel the 22. Okay, so I'm going to figure out what is 22 minus 5. It's 17. So we're going to have 22 factorial over 5 factorial times 17 factorial. If you rewrite this as a factorial, 22 times 21 times 20 times 19 times 18 times 17 factorial, and on the bottom, 5 factorial times 17 factorial, the 17 factorial can cancel, save you a little bit of time. Multiply the top, 22 times 21 times 20 times 19 times 18, and then you divide it by 5 factorial. There is a factorial button on your calculator. Your answer, the combination, total number of combinations you can have is 2,334. Now they ask us, out of this total number of possibilities of a grouping of 5 books, we have 2 favorable outcomes. The first favorable outcome would be to choose volumes 1 through 5. The last favorable outcome, or second, would be to choose the last 5 volumes, volumes 18 to 22. So we have 2 favorable outcomes. Now we're going to use this up here, this formula, to find the probability. Our 2 favorable outcomes, the first 5 or last 5, over our total number of combinations. 2,334. That's the total number of outcomes we could find. You can reduce that down, and it ends up being about 0.00008. If you move it over, it's going to be 0.008%. I'm not too worried about the percentage. So that's how you'd find if you had picked the first 5 volumes or the last 5 volumes. Example 3. It says a calculator is programmed to generate random integers from 1 to 100 inclusively when the enter button is pressed. If the enter button is pressed twice, what's the probability of getting a multiple of 20 and then a number greater than 90? So on your first time you press enter, what's the probability of you getting a multiple of 20? Okay, so we're looking for the probability of a multiple of 20 and then a number that's greater than 90. So multiples of 20 from 1 to 100, it's 20, 40, 60, 80, 100. So we have 5 multiples out of the total number 100. Okay? This is for multiples of 20. Our next one that we're trying to find is a number that is greater. On our second time, we press enter. What's the probability of us getting a number greater than 90? Well, there are from 90, a number greater, 91 through 100, that's 10 favorable outcomes, and the total number of outcomes is 100. To find out what both of these are together, all you have to do is multiply them together. Now I'm going to do a little bit of reducing. Cancel those. You have 5 over 100 times 1 over 10. Another canceling we can do is cancel this. 5 goes into itself 1 time, and it goes into 10 2 times. So we're left on top with 1 times 1 and 100 times 2. So 1 over 200. If you want to change it to a percentage, you're more than welcome to. Next, it says a bag contains 2 red marbles and 6 blue marbles. What's the probability of picking a red marble, keeping it out of the bag, and then picking a blue marble? So you need to find first the probability of picking a red marble. That's what you want to find first. Then if you keep that red marble out, you're left with less marbles. You want to see what the probability is of picking a blue marble after you take the red marble out. So first, the probability of pulling a red out, we're going to use our formula, the number of favorable outcomes over the total number of outcomes. We have 2 red marbles, and the probability or the number of favorable outcomes of picking a red is 2 over the total number of outcomes. 2 plus 6. You just add your total number of marbles in there. Okay? Next, what about for the blue? The probability of picking a blue marble. We are going to keep the red marble out that we picked. So now we have 7 marbles in there. 1 red, 7 blues. What's the probability of us picking a blue marble? We take the total number of favorable outcomes, which is 6, over the total number of outcomes. In this case, it's 7. So we don't have the same number of total outcomes in these. If you want to find the probability of both of them, first picking a red marble and then a blue marble, you multiply them together like we did in our last example. So the probability of picking a red first, keeping it out, and picking a blue is 2 over 8 times 6 over 7. Always see if you can reduce anything. 6 can be reduced by 2, you get 3. 8 can be reduced by 2 and you get 4. The answer is 2 times 3 over 4 times 7. And you can still reduce this. 6 can be divided by 6 can be divided by 2 and you get 3. 28 can be divided by 3 and you get 14. So the probability of picking a red marble first, taking it out, and then picking a blue marble is 3 over 14. Last example, example 4, talking about the odds of an event. It says a bag contains 2 red and 6 blue marbles. What are the odds of picking a red marble? So the odds of a favorable event is just slightly different than probability. Probability, it's the number of favorable outcomes over the total number of outcomes. For the odds of an event, it's the number of favorable outcomes over the number of unfavorable outcomes. So we want to pick a red marble. So I'm going to write this out. Number of favorable outcomes over the number of unfavorable outcomes. We're talking about the odds now, not probability. So first, if we want to get a red marble, there's 2 red marbles. So we have 2 favorable outcomes. For the number of unfavorable outcomes would be 6 because there's 6 blue marbles. So our answer, if we reduce it, is 1/3. These are the odds of us picking a red marble. The last one is another odds question. It says the odds in favor of an event are 5 to 2. And you can write this as 5 over 2. That's another way to write it. What's the probability of the event? Okay. The probability of the event is your favorable outcomes over all of your outcomes. So here we're combining the odds with probability. They're just slightly different. They told us our odds, which is favorable over unfavorable. So this is favorable, and this is unfavorable. Right here, the favorable outcomes is going to be the same. It's going to be 5 on top. This is not all of the outcomes. This is the total number of unfavorable outcomes. So if you want to find out what all of the outcomes would be, you just add the top and the bottom together. 5 plus 2 is going to be all of your outcomes. So the odds were 5 to 2, and they said, what's the probability of the event? It's 5 over 7. Now your homework is lesson 55, practice questions A through H.